Hi, welcome to Galaxy Installation with Ansible, the tutorial. My name is Nate Coraor. I work for the Galaxy project at Penn State, and I administrate the usegalaxy.org public server. So we're going to be covering today the installation process of Galaxy using Ansible. And you should have already watched the Ansible tutorial to learn a little bit about what it is and how it works, and what its configuration and setup is structured like. So we use Ansible to install Galaxy to ensure consistency, make it easy, and because the folks who administrate the large Galaxy servers who've put this course together for you all use Ansible to deploy their servers. So when you deploy your Galaxy server using Ansible, you're getting a lot of reused and best practice workflows for, not Galaxy workflows, but administration workflows for assembling your Galaxy server and running it in a best practice production manner. So looking through the tutorial here, we'll start by talking about the structure of the Galaxy playbook and what all goes into it, all the different components, and how it goes together to make your Galaxy server. And then we'll actually run through the process of installing Galaxy, including its dependencies and the pieces of software that it works together with, so databases, web servers, and so forth, Galaxy itself, and we'll log in and set up a couple of configuration files that are useful for running Galaxy. And then at the end, we'll talk about the production and maintenance of Galaxy server, how it stays updated, and how to upgrade Galaxy, and so forth. As you can see in this box here, all of our roles that we use, so the Ansible roles, are designed to be compatible with both enterprise Linux, so Red Hat, CentOS, and so forth, and Ubuntu. It says 1804 here, but we're actually running 2004, and other Debian variants. So if your system is not exactly like the ones that we use during the trainings, which are Ubuntu 2004, that's fine. If it should, what we do here today should work with any modern Linux system from these popular distributions. And if there are any differences between what you need to configure on an CentOS system versus Ubuntu, we try to list those here in the tutorial. So on to the Galaxy playbook. So we're going to be using the official Galaxy role for installing Galaxy. This is found in Ansible Galaxy, which is not of any relation to our Galaxy. It's their name for their sort of app store where consumable, reusable pieces like roles can be uploaded and shared, or similar to Galaxy's toolshed in that regard. And so we have published the roles that we write for other people to use and that we use ourselves to Ansible Galaxy. And the role that does the task of installing and configuring Galaxy is called Galaxy project.galaxy. Most of the roles that we use today will be under the namespace of either Galaxy Project or Use Galaxy EU. And that just tends to denote which organization, either the US-based or Europe-based organization, originated the roles. But we work closely together, and all of us have contributed to each other's roles at this point. The Galaxy project.galaxy role is very configurable. It can do almost anything, but we try to make it as easy to use as possible without having to configure it very much. So we're going to start with just a few variables that we'll talk about, and we'll talk about more as we go through the training. But in general, it can do a lot, and the documentation for the role, as well as the defaults file for the role, are the best places to look to figure out all of the different things that you can do with it. And I'll mention this again, but you'll probably find as we're going through this, like, how would you know to set this variable? How would you know to at what values to set it to? And the answer is always the role documentation should explain that for you. So the important variables that we're going to be covering here at the beginning are Galaxy root, Galaxy commit ID, Galaxy config, and Galaxy server dir. Galaxy root is, there are numerous ways that you can lay out a Galaxy server on the file system, but the one that we typically use the most is this Galaxy root, where there is one root directory somewhere on your system, and Galaxy gets installed underneath there. So there are separate subdirectories for things like the config files, for the Galaxy code itself, for Galaxy's virtual env, where all of its Python dependencies are installed, for its the tools that you install from the Galaxy toolshed, and so forth. But everything lives under that Galaxy root. Galaxy commit ID controls what version of Galaxy you're installing. So you can either set it to a specific commit where it will never change, or you can set it, and in most cases, this is what we do, and it's what we'll do in the tutorial. You set it to a branch so that you are running the latest commit on a specific version of Galaxy. Galaxy config is a large dictionary variable, or hash in Ansible. The dictionaries are referred to as hashes, but it's the same thing, where you set up the contents essentially of Galaxy's main config file. If you've ever worked with Galaxy before, that's called galaxy.yaml, and the contents of that will go into this Galaxy config variable. And then Galaxy server dir is where the Galaxy code lives, but this is automatically set for you based on Galaxy root, but you'll see it referred to a fair amount. Ansible gives you a lot of places to store variables, but we recommend that you set these in the Galaxy servers group variables file. The reason for this is that we're going to define a hosts file or inventory file that specifies which hosts in our inventory are Galaxy servers. This ensures that the variables that we set only apply to the Galaxy servers. And in some cases, you can have overlapping variables where it wouldn't make sense for those to be set on other hosts in your inventory. For this training, it doesn't make a difference because we only have one host. But as your Ansible infrastructure grows, you're going to want to think about which files you define your variables in. So when you begin to execute a role, everything starts in the roles tasks main.yaml file. And if you were to go and look at that file in the Galaxy project.galaxy role, you'd see that it does a number of things, which mostly involve including tasks from other files in the tasks directory. But those steps that are run through in that main tasks file are these. You're going to clone or download Galaxy, manage its configuration files. You're going to fetch the dependencies for Galaxy's Python application, manage the mutable setup. So that means dealing with the config files that Galaxy writes to itself. That's what we mean by mutable. Manage the database, and then build the Galaxy client application, the JavaScript application. So we'll talk about each of these steps in detail. So the first thing that's going to happen is to clone Galaxy. This is done using Git, Ansible's Git module, and is the primary way to install Galaxy. There are a couple of other options, but generally to have an up-to-date running Galaxy server, production Galaxy server, you want to use the git clone method. So the role is going to clone it if it's not installed yet, or it'll update it if you have set that commit ID variable to a branch, and there are new commits on that branch. It then tells you if it's the version, the git commit ID changed between what it was before and what it is after running that. It then creates Galaxy's virtual env. And this is a Python abstraction that creates sort of a virtual Python interpreter where all of the dependencies that Galaxy has can be installed in a way that won't affect other Python applications on your system. So it creates a virtual env with nothing in it, and then it updates pip, which is the package manager for Python, to the newest version. And then it removes any PYC files. So these are Python bytecode files. They are essentially compiled forms of the Python code in .py files. And if they're left behind, let's say in an update to Galaxy, we remove a .py file, move it somewhere else, whatever. If the PYC files are left behind, you can have some weird interactions. So there is a script that runs as part of this cloning process to make sure that no PYC files are left behind, and then it recompiles all of them based on the current .py files. All right, so after that, Galaxy has been cloned to the disk and is ready to be configured, which is the next task. So the static configuration then proceeds. We create directories for the Galaxy configuration files. Any config files that we've specified are copied over. Any templates that we've specified are copied over. So these are two different things, and you'll see below how these are addressed. But essentially, config files are files that we copy unmodified from the Ansible playbook, and templates are ones where we need to fill certain values in out of Ansible variables or whatever. And then finally, the galaxy.yaml file itself, which is Galaxy's core configuration file, is deployed. The additional configuration files that you can install with Galaxy, many of them are not required, but as you add more features or enable more features on your Galaxy server, you may end up adding some of these. So here's an example from usegalaxy.eu. And for example, you have this Galaxy data types configuration file. This is one that's commonly modified on different servers if you have your own custom file types, data types that you want to define. You can see here that everything in this Galaxy config files variable, this is a list, which is what this little dash here indicates. And each member in that list is a hash with keys source and dest. And the source means that the file underneath in your playbook at the path files galaxy config data types conf.xml will be passed to a destination that is this template variable. So you can see these two brackets or two curly braces rather are around either side of this variable in the middle, which will be filled in by Galaxy with it, or filled in by Ansible with its value. And what is its value? Well, it's defined, eventually we will define this in the Galaxy config variable. So Galaxy config is a hash with key Galaxy, and then in that key, there is a data types config file key. This corresponds, again, to the galaxy.yaml config file if you're already familiar with Galaxy configuration. So you can see that this structure up here, Galaxy config .galaxy.datatypes config file corresponds to the Galaxy config Galaxy data types config file down here in the Galaxy in the variables. And the reason that we do this is pretty important, and it's explained in this box down here. It's because we only want to define the path to this config file once, right? This tells Galaxy where it is when we define it here. And this tells Ansible how to install it from our playbook. But we reuse the value here that we've defined down here because we don't want that to ever become out of sync. Otherwise, you're going to have errors when you run your playbook. Let's say I just set destination here to an absolute path instead of this variable. I set it to, /serve galaxy config data types conf.xml. That would work. It would get copied to that path. But if I ever changed where I wanted that to go, I changed this galaxy config dir, whatever, then Galaxy would start reading the data types config file from a different path than where we were actually copying it to. So this is sort of a best practice to use. Always try to make sure that if you have defined a path or anything in Ansible in one place, that everything else that needs that value refers to that one place so that you only have to change it once. Okay, so the next step then is to install dependencies. And this happens using Galaxy's requirements file. So inside the Galaxy source code for each version of Galaxy, there's a list of Python packages that have to be installed and all the versions that they're installed at. We pin our versions, which means these are the versions that we know that this Galaxy release works with. And those get updated regularly with new versions of Galaxy. So we're going to install all those into the virtual env, or rather Ansible will do that for us. And then there are a number of conditional dependencies. So the first step there is all of the dependencies that are required no matter what. And then the second set is any that are necessary based on the features of Galaxy that you've enabled in the config file. So the most obvious one of these is, or commonly encountered one of these is when you enable Galaxy to use PostgreSQL as a database backend. By default, it doesn't come with the actual dependency that is needed to use that. But once you enable the option in the config file, it'll then install that additional dependency. So these are all installed into the virtual env. Then it moves on to setting up the mutable config files, which I said are the ones that Galaxy writes to itself. You do have to be aware that these files exist. They get written to when you do things like install tools from the toolshed. But generally, you're not going to modify them yourself. So the role needs to make sure that they exist for the first time that you run Galaxy, and it will do that now if they don't exist. The next step is to manage the database. So Galaxy's database schema is versioned, and with each new Galaxy release, you may find that there are new versions of that schema that need to be updated. So the steps that happen in this section are to obtain the current database schema version, and then figure out what the maximum version is, what it should be upgraded to. Then if there is no current version at all, then the database is created from scratch. If there is a current version and it's not the same as the maximum version, then the process will be run to upgrade that schema. And then finally, the Galaxy client application will be built. So Galaxy is two large components. It's a server backend that's written in Python, And then it's a client application that gets delivered to the browser written in JavaScript. And that client application has to be built, which means fetching its dependencies, bundling its components, uglifying the code, and so forth, so that it is delivered to the client as quickly as possible. So this process takes a long time, but you will see that it essentially runs, and for every time that the Galaxy code has been updated or changed. So if changes were made that require a restart of Galaxy, we use the Ansible notification and handler system to perform that action. And for a long time, there was no built-in method to do this. You had to define your own handler. Now that the role will automatically configure systemd or Galaxy to start with systemd for you, this can be done automatically. But be aware that if you're deploying somewhere where you aren't able to use systemd to run your Galaxy server, you may have to set this Galaxy restart handler name and define your own Ansible handler that controls how Galaxy restarts. So if you want to look through the role and figure out what other variables can possibly be set, these are all in the defaults file linked here, and you can see all of the possible things that can possibly be done. So in summary, to recap, the steps that take place: Galaxy is cloned, or it's updated if it's already been cloned and there's new commits on the branch that you're following. Virtual env is created if it doesn't exist. Configuration files are installed. Any missing dependencies are installed, which the first time that you run is all of them. The database is created, and if any updates are needed to the schema, those are applied. And then the client application is built and deployed. So you could do this all yourself, or you could make your own role that does this, but the Galaxy project.galaxy role that we've written and developed over many years does all this stuff for you. And we keep it up to date so that it can always work with the latest Galaxy changes. Okay, we're ready to get our hands dirty and start installing Galaxy. So before we install Galaxy itself, we actually need to install some of the prerequisites. And the first of those is going to be the Galaxy database and all of the Ansible roles that we use to actually install Galaxy. So if you are running this tutorial as part of a Galaxy admin training course, then all of these things in this box here should be taken care of for you. But just to show you what needs to be done, we'll walk through these. So you need to have Ansible installed on the machine where you will install Galaxy. We can check that here by running Ansible-version. You can see I'm running 2.11.1, which is fine. Actually, in a production setup, you would be more likely to run Ansible from another system. I run it from my laptop or desktop in my office or other servers, anywhere with an SSH connection to the systems that you're trying to manage. But for the purposes of the training, we have you run it directly on the VM where Galaxy will be installed, because that allows us to make sure everything's a nice controlled working environment. So we check to see that Ansible is at least version 2.7, and we'll create an inventory file, and we have to put our host into a group called Galaxy Servers, which we'll do in the next step. The VM has to have a public DNS name, which is true for all of the VMs set up for the admin training. Have to have Python 3 installed, which we do, 3.8.5 in our case. And we'll have to put the DNS full DNS name into our inventory file. We set that up. That's fine. And the ports that we need to access for SSH and the web and so forth are open on our VMs. Okay. And we are running on Ubuntu 20.04, so all these instructions should work for us. So we are ready to get started. Now, the first steps will be to write our playbook and set up the basic things needed for it to run. So we're going to start by creating a directory, Galaxy. Let's see into there. And then we'll create a requirements.yaml file with the contents that you see here. Requirements.yaml. As you can see, everything in this training where you have to enter text is shown in the form of a diff. So in this case, you can see that the old file here was dev null, new file is requirements.yaml. That's because this file didn't exist before. If the minus file, the file that you're changing from, is dev null, that means that the file that you're creating is brand new. So here we've specified a number of Ansible roles, and these are going to be installed from Ansible Galaxy, that Ansible toolshed of no relation to the Galaxy project that we talked about before. And so we've specified all of these roles that we're going to use and the versions that we want to use of those roles. In most cases, these are the latest versions of all these roles as of the time of recording. And I'll tell you what each of these roles does here. So the first one, we've talked about it quite a bit already. This installs and manages Galaxy. Second one is going to install Nginx, the web proxy server that will sit in front of Galaxy and serve web requests out to clients. The third one is for Postgres, the database, which will sit behind Galaxy and store all of its persistent data, such as user accounts and all the metadata about the data in Galaxy and so forth. The fourth one then is PostgreSQL objects, which is separate from the PostgreSQL role, which only does the tasks of installing the database, configuring it, its config file, and dealing with the backups of Postgres. But there's a separate role that we have called PostgreSQL objects to do the creation of databases and users in the database and so forth. Managing of database permissions as well. The next one will be a pip module. So pip, as I mentioned before, is Python's package manager, and this module from Geerling Guy, who is a prolific Ansible role author, will install pip for us. We'll also be using this mini conda role. So conda is a prepackaged version of Python and a package manager that can install all kinds of different packages. They don't have to be Python packages. So it's a standalone system that sits on top of your operating system, doesn't depend on apt or yum or one of those other systems. Galaxy uses this to install dependencies, although this training has later modules in this training have focused on using Singularity for dependencies, but Galaxy is still very closely tied to Conda to provide tool dependencies when containers aren't used. And then finally, we have the Use Galaxy EU certbot role, which will be used to fetch SSL certificates for our web server so that it's secure. Okay, so we are ready to install these roles, which we do with this command here, Ansible Galaxy install -p roles -r requirements.yaml. And you can see it's going out and downloading all of these different roles and extracting them to the roles directory. So if I take a look at roles, you'll see that all the ones that we listed are installed, and in fact, it installed them at the versions that we specified in the requirements file. Okay. Next, we're going to create a config file for Ansible, ansible.cfg. And this allows us to define some defaults that are kind of nice and handy to use that will make our life easier as we run our playbook. So in the same directory here, I'm going to create an ansible.cfg and paste this stuff in. And what this is, we've forced Ansible with this interpreter Python option, we force it to use Python 3, even if it finds Python 2 in the system. This should save us some headaches later, as Ansible can have some dependencies on certain Python modules that have to be installed on the system, and we're only going to install the Python 3 versions of those modules. We've also set the inventory option here to hosts, and this is a file name, this hosts. And what this does is it means that we don't have to specify using the -i flag on the command line every time that we run the Ansible playbook command to specify what the hosts is. This just sets it as a default. And then retry files enabled. Anytime that Ansible fails, it leaves behind these retry files so that you can pick up from the point where it left off, but they don't work all that well, and they clutter up your directory, so we disable those. Okay, and we're done in there. There is a note in here in the training that if you're running Ansible over SSH, which you probably will in a production environment, that you might want to enable this pipelining option for SSH. It's very nice. If you click the link, it'll explain more about it. It essentially will make your playbook run much faster, most likely. Okay, now we need to create the hosts file. And this should have a group, an Ansible group in it called Galaxy Servers. This file is basically INI format. And so you can see the group is an INI section name. And then the members or member, in our case, just one of that group is going to be our Galaxy server. So in my case, I'm using GAT42.be.training.galaxyproject.eu. And in here, you have to put your full actual host name that you want your SSL certificates to be assigned to. And so this needs to be the address that you'll access your Galaxy server over the web at. If your server's DNS host name is different than the host name that your Galaxy server is going to run as, then you have to make some changes here. But this is very important. It has to be the correct host name. So we also want to set the Ansible connection to local. This means that instead of the default, which is SSH, we're just going to operate on the local system only, because otherwise it would try to connect to itself over SSH, which we don't want to do. All right, and finally, we need to set Ansible user. And in this case, it's the username that we connect to the system as that has admin privileges or sudo privileges. And that's going to be Ubuntu in our case. Okay, I believe that's it. Let's take a look. Yep. Connection local, Ansible user Ubuntu. Just make sure that if you are copying this stuff out of your hosts, that you change the host name to be your correct host name. It's not going to be this. So that should be it. Done with the basic setup here. So you should see in your Galaxy directory the ansible.config, a hosts file, requirements.yaml, and the roles directory. And now we are ready to install Postgres. But first, we'll take a quick diversion to talk about Postgres itself and why we use it. Okay, so a little bit of a chat about databases. So Galaxy uses a database for all the objects that you work with in Galaxy and all of their relations. So that means things like users, histories, datasets, and workflows. Now, it says datasets there, but as you can see down below, we don't actually store the datasets themselves. We store information about the datasets. We store metadata about the datasets in the database. The data sets themselves, which are generally files anywhere from a couple of bytes all the way up to many, many gigabytes, are stored on disk, and you can control where those live. So we store these objects in the database, and we use it for things like persisting the state of Galaxy jobs, so that if you restart the Galaxy server, we know what jobs were running at that time, and so forth. By default, Galaxy, or not by default, Galaxy, the only way that Galaxy can run is using the SQL Alchemy database abstraction layer. So what this does is it allows us to write Python code that interacts with stuff in the database without having to directly write SQL. And so this makes for much more powerful ability to program, but it also means that as an abstraction layer, it can have multiple different database backends behind it. And so by default, when you clone and start and run Galaxy, it actually uses a SQLite database instead of Postgres. And you can find this database if you were to start Galaxy up without switching it to Postgres, you could find it at database/universe.sqlite. So this is actually really nice for development. Most people doing development on Galaxy don't run Postgres because it's quick and easy to get a SQLite instance of Galaxy up and running. You don't have to there's no external services that you have to deal with. But when you're running a production Galaxy server, you want to have a much more powerful and scalable database. And for that, we recommend Postgres. Because we use a database abstraction layer, it is possible to use other things, including MySQL, but we don't test on it. We don't use it and don't recommend it unless you have no other option. A note about sizing the database file system. So we rarely delete things from the database. When you delete a user, when you delete a history in Galaxy, most of the times we're not actually deleting that row out of the database. We're marking it deleted. So there's a column that says deleted, and we set that to true. So because of this, the database just generally is going to grow and never decrease over the life of your Galaxy server. For most cases, I would suggest that you start with at least 20 gigs of data for the volume where the Postgres database lives. If it would be difficult to expand that volume in the future, then maybe consider starting with at least 50 gigs. 8 to 16 gigs of memory is usually sufficient for Postgres. I recommend that you run it on a separate server from your Galaxy server. In general, the more things that you can separate out to different systems, the easier it is to figure out what's going wrong when you have resource problems. You have fewer issues with things colliding with each other and consuming and competing for resources. So strongly recommend running that on a separate system if that's possible for you. In the case of our training, we're going to, of course, run it on the same VM as Galaxy. For the configuration, in the galaxy.yaml file, there's a configuration called database connection. And this is just a URL-ish string that is passed to SQL Alchemy, and that's how it determines what the database is. So in the default option here, it's going to be the universe.sqlite file under database. For Postgres, you have this URL where you can specify a database name, you can specify the host or a different directory where the socket lives if you're running on a local Galaxy or a local Postgres database. You can also specify the user and password, which is usually required if you're connecting to a remote Postgres database. So when Galaxy first starts up, it creates its entire database schema, and if the database is empty. When you upgrade Galaxy, sometimes we have to make changes to the schema, and these are versioned. And so starting up Galaxy performs a migration process, or tells you that you need to perform a migration process, which is done with this manage-db script. Now, in the case of running Galaxy or upgrading Galaxy with Ansible, this is taken care of for you because there's a migration step built into the Galaxy project.galaxy role. There are some options that you can tune if you need to. There are a number of workers that you can keep around in order to handle connections to the database that you can increase if needed. Typically, you'll only know if you need to do this if you start seeing error messages in your Galaxy log. This is a nice option, server-side cursors. So if you have a very, very, very large result from the database, by default, that will get sent back to the Galaxy server, which then has to load the entire thing into memory. So if you are noticing that your Galaxy server processes are crashing because they're running out of memory, you can set this option, which keeps the result set in Postgres on the Postgres server, and it just iterates and returns sets of results as you need them. The downside of this is that it makes it slightly harder to see what queries are running at a given time. But the upside is that it can drastically reduce the amount of memory being used on your Galaxy server. There is an option to log when queries go over a certain amount of time or take a certain amount of time to execute. This can be very nice in trying to find performance problems with your Galaxy servers, figure out where maybe there's an index missing. Of course, we as the developers of Galaxy try to make sure that there are indexes on every table and every column that might need it. But there are occasions where you may find that you're having problems with a particular query, and this can help you find those. It is also possible, so when you install tools from the toolshed, the records for those tools are written into two different places. One is a file that you'll encounter called shedtoolconf.xml, and this instructs Galaxy on how to load the tool. And then there's a number of tables in the database that are used to do things like show which tools are installed when you're browsing the administrator interface in Galaxy to see which, the list of currently installed tools. That install database can be separated out into a different database connection. So it could be another Postgres database, or in my case, for usegalaxy.org, I make this a SQLite database. It's very low traffic, low transaction, so there's no contention problem with using it in production like there is with using SQLite for the rest of Galaxy in production. And it gives you a nice way to deal with the cases where tool installation may fail, which was maybe a bigger problem a number of years ago when that process was not as robust as it is today. But it means that if you back up this database and the shed tool conf file before you install a tool, and that installation fails, you can just restore the backed up copies, which is pretty nice. It also allows you to do some other things like bootstrap Galaxy installation with pre-installed tools that then you can ship out to someone else with those tools pre-installed without having to preload something in their Postgres database. If you need to, as an administrator, work with model objects in Galaxy directly, this is sort of an advanced thing. You can do so via the DB shell script that comes in the Galaxy server directory. And here's just a little example of how you do that. But as an administrator, I find that it's much more easy to work with the Galaxy, the database directly using SQL queries. And over time, a number of us who are pretty heavily involved in Galaxy administration have gotten together and published our queries into this wonderful script called GXAdmin that Helena wrote that wraps them all up, makes them very nice to deal with. So you just run a single command from the command line, and it spits out lots of cool stuff about what's in your Galaxy database. Very useful for debugging problems when you're trying to help figure out what's going on with user issues. There is a training in the Galaxy training network about it. And if you're doing a full Galaxy admin course, we will talk quite a bit more about GXAdmin. Okay, thank you very much. Okay, we've got our Ansible directory set up and we are ready to do some installing. The first thing that we're going to install and configure is PostgreSQL, the database. And just a bit about how this configuration works. Postgres has its own user database separate from the system's database. So, and it has lots of different ways that it can authenticate users to the database. When you're running on the same system, when you're connecting to a Postgres database on the same system, the easiest method to authenticate users is using the peer system, or peer method, which just says if the user on the system has the same name as the user in the database, then they are the same user, and let them in without password. So that's what we're going to do for the training course. Now, if you're running your Postgres server on a different server than the Galaxy server, you're going to end up doing something different, probably using password authentication. So make sure that you check the Postgres documentation to understand how all that is set up. So we need a Postgres user in the database that matches the user that we're going to run Galaxy as. The user that we're going to run Galaxy as is just going to be named Galaxy, and that user doesn't exist yet on our system, but we're going to use Ansible to create that system user, and we're going to use Ansible to create that Postgres user. Additionally, we're going to use the Postgres role to create backups of the Postgres database. Normally, these would be stored on some external system. In our case, we're just going to stick them in this /data backups folder and pretend that /data is some shared remote network file system where this all gets backed up. So that if our VM crashed, we would be able to restore the backup. So let's get started. We need to create our group variables file, which we will be in and out of a lot in this training. So you'll be very familiar with it. So the first step will be to create the group vars directory. Okay, group vars. And then we'll edit this file. Group vars, galaxy servers.yaml. and we'll paste in the contents. And then we'll discuss them. So we've got these options here. Pip virtual env command will ensure that when we create a virtual environment, which we actually create a few of them throughout this training, one for certbot. Later, we'll use it when we do the training for training infrastructure as a service, but also for Galaxy itself. We make sure that we're going to use the Python 3 interpreter and not Python 2. So that's what all three of these options essentially are for. And then, well, the third one's to install pip and make sure that we install the Python 3 version of that. Next, we're telling the PostgreSQL objects role that the name of the user that we want to create in the Postgres server is named Galaxy. And then we've also said that we want to create a database named Galaxy owned by the user Galaxy. Now, how do we know that these variables that we're defining, this PostgreSQL user, objects users, and PostgreSQL objects databases actually do anything useful? It's because in the documentation for the PostgreSQL objects role, it explains how to use these variables to do these things, to create users, to create databases, and so forth. And then, so you'll also notice that the variables that are used by a particular role are typically prefixed with the role name. So the PostgreSQL objects role uses variables that start with PostgreSQL objects, and the PostgreSQL role starts with variable names that start with PostgreSQL. This isn't a hard and enforced role, but any role that I write, I make this the rule, that any variable that a user will set that affects that role should begin with the role name. Okay, so next we're going to configure the PostgreSQL backups that we talked about. We're going to set the directory where these are stored to /data/backups. And then we need a local directory where it installs the scripts that are used to initiate the backups. It keeps a working copy of the in progress write ahead log, which is a Postgres specific term for where it stores transactions that haven't been flushed out to be backed up yet. So we're using a little bit of Ansible magic here to make this work. Again, we've got these two curly braces that denote that this is a variable expansion. So you might be familiar with other languages where you'd expand a variable using, a $sign or something like that. But in Ansible, it actually uses a templating language called Jinja2, and variables in Jinja2 are templated with these double curly braces. Anytime that a double curly brace like that is going to start the variable name or variable value, it has to be quoted, right? So if I were to remove these quote marks, then the YAML interpreter would get confused, because in YAML, you can write a dictionary like this. This is a dictionary under the variable named foo, where that has a key named bar and a value named baz, right? So this is a dictionary. So to differentiate between a YAML dictionary and this Jinja2 template, you have to have the quote marks around anything that starts with this curly brace. Okay, so then what else is going on in here? Well, we have a string tilde Postgres, and then this pipe and expand user. And what this does is it takes the tilde Postgres and it turns it into the actual path to the Postgres user's home directory. So we use this syntax so that this training can work on both CentOS and Ubuntu, which don't have the same home directory for their Postgres users. If we had hard-coded the path to what it is for Ubuntu, then it wouldn't work for CentOS. So that's why we use this expand user here. I should mention that expand user is what's called a filter. There are a ton of filters in Ansible that do different things to the thing that they're modifying. So the thing that they modify is on the left, and then the filter is on the right. And you can chain lots of these different filters together. You will see more of them throughout this training. All right, we are done in the variables file for now. We will be back many times. The next thing that we need to write is our playbook file. So we'll do that. If you actually CD'd into the group vars directory, make sure you back up and you're back at the slash, the ~/galaxy directory. Okay, so I'm going to open up galaxy.yaml, which is a new file. And we need to do these things. We need to add a pre-task to install the Python 3 Postgres library called psycopg2. We need to tell the playbook to run a role called galaxy project.postgresql that we've talked about. And then we need to run the PostgreSQL objects role, and we need it to run as a different user. So you may recall that in our hosts file, we told it that the user that we're going to connect to this host and run as is Ubuntu, right? But when we go to add users to the database, the Ubuntu user or the root user, neither of those actually have permissions to interact with Postgres. We need to do that as the Postgres user. And so that is what these become and become user options are for. I'm going to grab the contents of this, stick it into my galaxy.yaml. So what this says, this is what's called an Ansible play. It's at the top level inside the playbook, and it starts off as a list element. You can have multiple plays inside of a playbook, but here we've only got one. So there's a list. This has hosts, and it says, this is telling Ansible, okay, connect to all of the hosts listed in this hosts directive. Well, what's listed here is Galaxy servers. And if you recall, that is the name of the group that we put our host name into for our Galaxy server in the hosts file. So that's where that comes from. Then we have a become option down here to, with the value true. This tells Ansible that we need to become a different user when we run these run these tasks, and that user is on the next line. It's going to be root. So obviously, when we're installing packages on the system and so forth, that has to be done as root. So this is how it's set up in here. Then we have the pre-task to install the Python 3 psycopg2 package. So this task has a name. This is just a descriptive thing. And then there are a ton of Ansible modules. These are the things that ship with the Ansible software that do the actual work of modifying your system, copying files, all the other things. Roles then are just collections of tasks that invoke these modules. And so the module that we're using is the package module, and it takes an argument. It takes many arguments, but the only one that we need here is name. You can find the Ansible documentation on the package module to find out what the other options are and how to use it and all that kind of stuff. Okay, so we want to install this one package, and then we want to run these roles. And you can see here, first we've put the PostgreSQL role with no, just by itself on this line. And the reason for that is that it's sort of a shorthand. If you're not needing to specify any other arguments for this role, you can just put in the string Galaxy of the role name, Galaxy project.postgresql. But down below here, because we need to run the PostgreSQL objects role, as a different user than the default one defined up here, we have to preface the role name with this role colon. So we've got role and the name of the role, and then down here we have options to run this role as a different user than what we run the rest of the playbook as. And that's it for the playbook file. So what should we expect to see in our folder? Just looking in here, we should have an ansible.config, galaxy.yaml.groupvars directory, hosts file, requirements.yaml, and then the roles. You might have noticed that we've had some true, false, and so forth in here. And there are many ways to specify Boolean values in YAML. I tend to stick to true and false. Vim likes to highlight them better than, for example, yes and no. But any of those values will work with any amount of capitalization. But I try to be consistent. Okay. Now we are ready to actually do the first step of modifying our system. So we're going to run Ansible-playbook galaxy.yaml. And then let's see what comes out. So this is the process of actually running an Ansible playbook. You can see the things that were written into the play then become these output lines. And Ansible is very good about telling you what things it did or did not do, and what things it did that caused changes or didn't cause changes. And so the very first thing that always happens on a host is to gather facts. That means it figures out things about the operating system and so forth that you can use. That it creates a bunch of variables in Ansible that you can refer to later. The next thing then, this is our pre-task that we defined to install the Python 3 psychopg2 package. So we named it install dependencies, and that's what shows up right here. So it says changed. That means that it did the thing that we asked it to do. And then next, it moved down to the roles section of our playbook, where we said to run the Galaxy project.postgresql role, and it went to that roles tasks/main.yaml file, looked in there and said, okay, what do I do? You'll see that role is set up for multiple things, multiple operating systems. Because it gathered these facts, it figured out, okay, this is a Debian-based system, Ubuntu, and I'm going to read the tasks that need to be read to install on a Debian system. Runs through a number of things here. It says, okay, we're not using these pgdg packages, so I'm going to skip that, and then just install using apt the Postgres package that's native for this version of Ubuntu. So changed because it did that. All right. Now it looks up a bunch of information. Okay, what version of Postgres got installed? I need to know some stuff about that, and set some internal variables to figure out what it should do next. But what it ultimately decides to do is to set some configuration options that are default in the role, and also to specify how the backups are supposed to work. And we can take a look at those in a minute. It installs the pghba.conf, which is PostgreSQL's configuration file for access control to decide what users can connect to the database. And then it runs through the tasks of setting up backups. So create backup directories. So this is that ~Postgres on the Debian system resolves to varlib PostgreSQL. And under there, we have a backups, and then we have a bin directory and active. And this created that /data backups that we specified for the place where our backups would be saved. Installs the scripts used to create backups, and then configures Postgres to actually create the backups. Made a cron job to actually schedule and run the backups, which happens nightly by default, but you can change that to any frequency that you wish. That's for the full backup, but the backup system is constantly making incremental backups in between your full backups, so that if your Postgres server were to die at any point in the day, it should be recoverable up until pretty much the moment that it crashed. Okay. Then we schedule keeping a copy of the currently active Postgres write-ahead log, transaction log, and then we're done with the Postgres role. So this is the last task in the PostgreSQL role. We just make sure that it's running, which it is automatically when you install it on Ubuntu. The next thing is the next role that we define in our play, the PostgreSQL objects role. And what this does is create users. So you can see there's a number of tasks that it runs through in here. Drop databases. Well, we don't have any databases that we told it to drop, so it's not going to do that, just skips that. But we did tell it to create a user. So it creates the Galaxy user. And then down here, it's going to create a database, the Galaxy database owned by the Galaxy user. This is all the stuff that we defined in our group variables file. And then at the very end, because changes were made to Postgres's configuration file, a handler triggers, and these always run at the end unless something forces them to run sooner. A handler runs that tells Postgres to reload its configuration. That was done in the PostgreSQL role, but that happens at the end because handlers always happen at the end. Okay. So your output should look something like that. So you notice I walked through all of those changes. I don't normally look at absolutely everything that happens in here, but anytime that you see yellow or red text in here, which means changed or error, you absolutely want to be making a note of that and make sure that the changes that were made were the changes that you expected to be made. The system is, Ansible is only going to do what you tell it to, but sometimes you tell it to do the wrong things. Okay, why didn't we use -I in our Ansible command? We don't have to because we specified the inventory file in our ansible.config, so that's taken care of for us. Skipping no hosts matched. You can see this sometimes when you run the command, Ansible playbook command, essentially nothing happens. Why is this? It happens usually because of a typo somewhere. And there are a list of troubleshooting actions that you can take if that happens. Okay, so let's take a look at what our system actually looks like now. What did Ansible actually do? Because I can tell you that it did all this stuff, but we ought to actually confirm that it did make some changes. So first of all, I mean, we can say that there are now Postgres packages installed. I didn't show you that they weren't installed beforehand, but they weren't. And they have now been installed. And in etc PostgreSQL 12 main, you can see that there's some configuration files now. And curiously, there's this pghba.conf with a funny name on it. And this is Ansible's scheme for backing up files. So many of the roles that we use are designed not to just overwrite the files that it changes entirely. Usually, it will try to make a backup first, so that if something went wrong, you can fix it. So let's see what actually changed in here. Oops. And okay, so you can see the old version had this big long comment at the top that we got rid of. All the roles that I write, I stick this blurb in here so that if anyone edits the file by hand on the system, hopefully this will scare them off, to let them know that any changes they make are most likely going to be destroyed the next time someone runs Ansible. Okay, and so what else? It removed this network listening block because we don't need that for our server. If that was necessary, oh, sorry, this is replication, which we're not using. If that was necessary, then we could add it back in using the role. Okay. Additionally, in the conf.d directory, we have added a 20, or the role has added options to enable backups. So you can see this wall archive, that means write ahead log. It means that they'll be archived. We'll turn that on, and then we'll specify this script, which was installed by the role, as the script to use every time that the system wants to archive one of these write ahead logs. And then additional options get set in here. It created this file, but we didn't actually specify any extra Postgres options that we want to set. But there is an option in the role to specify additional parameters. And as you tune up a Galaxy server, you may find, oh, I need to increase the amount of memory that Postgres will use. That's pretty typical. I need to increase the amount of connections that it will allow. And when you set those options using the role, the Ansible role, they'll appear here in this file. All right. Additionally, we said there's a data directory. Oh, not readable. And the role created for us this data directory, and in there it created a backups directory. You can also see, in the ~Postgres directory that under backups, there is the bin directory where those scripts got installed for backups. And it's also already making the running copy backup of the active transaction log. That's what this file is. It's in the active directory, and this gets copied every minute out of the Postgres data directory here where it gets backed up. Okay, so we can also verify in the database that that the things that we wanted created in the database are there. So let's take a look here. psql-l run as the Postgres user will show us that there is now a database in addition to the 3 that come with Postgres when you install the Postgres and template 0 and 1. There is now a Galaxy database. And it's set to Unicode encoding and all that good stuff. And it's owned by Galaxy exactly as we told it to be. Finally, we can look at the Galaxy user. So we'll just connect to the Postgres server using the shell and run -d. You can see that there aren't any relations yet, but you can see that that the Galaxy user exists. Okay. So our database is set up and ready to go, and we're ready to install Galaxy itself. And we'll do that, and we'll also set a few basic configuration options at the same time. Of course, we definitely need to tell it to use Postgres instead of SQLite, but there are a few other things that we'll do as we go along as well. And we're also going to enable UWSGI mules. So UWSGI is the application server that starts and runs Galaxy and provides, you know, the interaction between the web server, the Nginx web server, and the Galaxy application. It's sort of the web component of that, of the Galaxy server. But it also does about a million other things. And one of the things that it does is process management and inter-process messaging. And we've leveraged this functionality, which it calls mules, to separate the job running functions of Galaxy into a separate service that will run under UWSGI. So on a normal Galaxy server where you don't configure any of this stuff, it's going to start up one process under UWSGI that starts the Galaxy server, and it serves web requests, it handles your jobs, it schedules workflows, it does all of these things in one process managed by UWSGI. It's a good idea for performance reasons to separate the job handling functions of Galaxy out from the web serving functions. And so that's what these UWSGI mules are used for. When a user clicks in the form to execute a job, that creates a row in the database for the job, and then whatever web server process under UWSGI received that request, it signals to one of these mules to say, hey, there's a new job in the database, can you go deal with it, handle it? And so then the Galaxy job handler mule picks that job up and submits it to a cluster probably, although in our first scenario here, we aren't going to connect a cluster. It'll just run locally. But either way, the job handler is going to be responsible for that job from start to finish. So we will set up those UWSGI mules. It's very simple to do and best practice to do it. So we'll do that. And then we need to create the actual Galaxy system user so that we're not running it as Ubuntu or root. Definitely never want to run Galaxy as root. There is some information here about how mules are not the only option. There are other ways to run Galaxy servers. So some production sites don't use mules. Use galaxy.org and use galaxy.eu. We do still run separate job handlers. We just don't run them as UWSGI mules. Be sure to check out that documentation for more information. So let's get to work actually getting Galaxy installed and running. We're gonna back in the Galaxy directory, in our home directory. I'm going to open up the playbook file again, galaxy.yaml. And now instead of this single package that we need to pre-install, we have a bunch more things to pre-install. And the reason for that, I'm not going to get too deep into this. ACL is necessary for Postgres or for Ansible to be able to run things as different users in certain scenarios. And then bzip2 and tar and stuff are needed for the mini-conda role. Git is of course needed because Galaxy itself is installed by cloning from Git. Make is needed to install or build the client, the Galaxy client application, and then virtual env we've already talked about. All right, so all those are needed, but by the way, the roles specify that these things are dependencies. So if you were building this up by hand and not having me tell you, or the training material tell you how to do this, you would the Galaxy project.galaxy role, for example, would tell you that it needs these things as dependencies. Okay. Now we need to add some new roles. The pip role, the Galaxy project.galaxy role, and the mini-conda role. So you can see here that become user is in fact a template variable again. It's not just Galaxy. Although the user that we're creating is named Galaxy, one good practice to get into is to try to not have the same variable defined in multiple places, right? So the system user is going to be named Galaxy. That's going to be set in our variables file, and we don't want to duplicate it here by typing Galaxy, right? We're going to refer to the variable that we're going to create in the variables file, so that if someday down the line we want to deploy a Galaxy server and we had to change the Galaxy username to something else, we didn't have to find it in multiple places and change it in multiple places. All right, next we're going to edit our group variables file and actually set those things that I was just talking about. So down here at the bottom, let's paste in the stuff in green. So what does this say? All of these variables control the Galaxy role, all the ones that start with Galaxy, and then we have the Miniconda ones that control the Miniconda role, both of which we just added to our playbook. So we'll go through each one of these. The Galaxy create user is pretty self-explanatory. It says if the Galaxy user doesn't already exist on the system, we want to create it. Galaxy separate privileges is a security best practice that we've built into the Galaxy role. It means that things that are not needed to be writable by the Galaxy user should be installed as a different user. So like in a non-privileged separated Galaxy installation, you might just install the Galaxy server and all of its config files and so forth as the Galaxy user. But then when the jobs, your users submit jobs, they run on the cluster, whatever, those jobs also run as the Galaxy user. The Galaxy server operating on the web runs as the Galaxy user. So in theory, if there were some kind of security issue with Galaxy itself, that allowed a malicious person to write to the file system, they could overwrite the Galaxy code, they could overwrite the Galaxy config file and do all kinds of stuff potentially more damaging than what they can do if those files aren't writable. So separate privileges is going to install the Galaxy code, the Galaxy dependencies, the config files and so forth as a different user. In our case, it's going to be root. And that way, if the worst case were to happen, they couldn't be overwritten. Okay, so manage paths is an option to make sure that all of the directories that are needed, where the configs are going to be stored, where the server is going to be stored, all that stuff gets created by this role. Occasionally, it's not really possible to use this if you run on network file systems where maybe the user that is running Ansible doesn't have permissions to create files on that or directories on that network file system. That's just a sort of a site-specific option that has to be enabled or disabled depending on what's going on your server. Okay, Galaxy layout is set to root dir. We talked about this earlier, that there are different ways that you can lay out the directories that Galaxy gets installed to, but in our case, we want everything under this /serve Galaxy, which is the next option, Galaxy root. Next, we have a Galaxy user. This is a YAML dictionary where we have the name key, and its value is Galaxy, and then the shell is bash. So this just is going to create the system user and the Linux system user named Galaxy and make sure that its shell is set to bash. But you'll also see back in that playbook, if I were to open that, oops, when I was talking about how you've got this Galaxy .name key. All right, Galaxy commit ID. Here we're setting this to the release 2009 branch of the Git repository that Galaxy is installed from. There are releases 3 times a year, and they correspond, and so the branch name is going to correspond to the year and month of the release. And then force checkout will obliterate any modified files in the Galaxy directory when it does a Git update. All right. Finally, we are going to pre-install Conda. Now, when you start up Galaxy, it installs Conda itself automatically. But since we start up multiple Galaxy processes at the same time in a production service, we pre-install it just to make sure that there's no race conditions with that. Although Galaxy has gotten pretty good about doing that itself. This is more of just a sort of a safety measure. Okay. Now we're going to set the Galaxy config option, which I did talk about before. This is essentially the contents of the galaxy.yaml file. Let me paste it in first, and then we'll talk about the things that we've put into here. So just at the bottom of the group vars Galaxy servers file, we're going to create this Galaxy config. My terminal doesn't render the pretty emojis, but you can see here. And you might want to make some changes here. You can change the brand. That's what will display on the top left corner of the Galaxy website. You can change the admin users maybe to your own email address. And then the rest of this stuff. So the database connection then points at the Galaxy database that we defined up here. So Galaxy Objects Databases, the name is Galaxy, and that's the Galaxy down here. And then on Debian-based systems, they change the default location of the socket that you connect to if you're making a local connection to the database, and that's what this var run PostgreSQL is for. We've also said that we want to store data sets in the /data directory. So if you recall, I said that we're going to pretend that /data is some big network file system that's mounted onto our Galaxy server, where we're going to store all of the big data, because this is where all of the user data is going to go. The Galaxy server itself doesn't take up very much space, a few gigs maybe for it and all of its dependencies, but the file path is where all the user data, so hundreds of terabytes over time are going to live. So you want to think about that one when you're setting up your Galaxy server. Not really worth talking about check migrate tools at this point. Just set it to false. The tool data path. This is where when you install Galaxy tools that need reference data that's managed outside of Galaxy, that's stuff that the files that tell Galaxy where that data is located goes into the tool data directory. And then there's this object store by. So until very recently, when data sets were created in Galaxy, they were stored in the file system by number. So in the database, there's a table called dataset, and that just increments. The first data set to ever get uploaded or created in Galaxy is number 1, second one is number 2, and so forth. And the old way of storing data then was to create a file on the file system under this file path called dataset_1.dat. And the second one is dataset_2.dat. And there's some subdirectories to make sure that you don't end up with a billion files in one directory, because most file systems can't handle that. But the point is that they were stored by the numerical ID. But there have been some performance enhancements that we've gained by storing them as the UUID that is generated uniquely for every single data set and stored in the database. And so this option is very much recommended for any new Galaxy server. If you have an old Galaxy server, you can also enable this for new data sets. Come talk to us to find out how to do that. And then the ID secret is going to be a randomly generated string that's used to generate all of the IDs in Galaxy. So you want to make sure that this is something that you set this to something and not leave it as the default. Otherwise, attackers can guess certain IDs. All right. So you may notice that there is a variable in this file called Galaxy Tool Dependency dir that we have not defined in this file, right? And the reason for that is that there are variables that get added to the Ansible runtime environment as the playbook runs. And so the first one of those I talked about already. It's these setup facts that happen when you connect to the server, figures out the operating system and all that kind of stuff. But then as roles get executed, those roles may set variables. And in fact, the Galaxy project.galaxy role sets a ton of default variables. And this Galaxy tool dependency dir is one of them. The Galaxy mutable data dir is one of them. So that's why we can refer to these things without having actually specified them. You can find all of them in the defaults file of the Galaxy role to figure out what other things you can reference without having to set them. Vault ID secret is not set, but we're going to do that ourselves shortly. Okay, so we mentioned that we were going to use mules to handle our jobs, and we'll set up the configuration needed to do that now. I'm sorry, that's still in the group vars Galaxy servers file, but now we're going to add a uWSGI section. So let me paste this in here and then talk about it a little bit. The most important thing here is that you need to make sure that the U in uWSGI lines up with the G in Galaxy. These should be in the same place. So I have two spaces in front of them. And this is because there's a uWSGI section of the Galaxy config file and there's a Galaxy section. If we didn't have this uWSGI section, then the role would put one in there for us by default. But we want to change some things. And most importantly, we want to add these mule options. So this is all we have to do here essentially to say, hey, start up a couple extra processes to do job handling for me. So we say mule, we have a list here of two entries, and these are just the file inside the Galaxy code that actually starts and runs the Galaxy server. So libgalaxy main.py, and then we assemble these into what uWSGI calls a farm. The farm's name is job handlers, and we say that mules number 1 and 2, so these two up here, are part of that job handlers farm. And by doing that, they automatically become job handlers. So there are a whole lot more options in here. The ones that you would have to change most often or need to worry about. The first one is the socket. This is the port that uWSGI is going to listen on, and Nginx, when we connect it to uWSGI in a future step here, is going to have to know this port number 5000. The processes and threads, so these are the number of processes and threads that will be started for handling web requests. So if you notice that it seems like your uWSGI server is struggling to handle the number of web requests that your users are creating, you can increase these values. Okay, So we talked about how there is this ID secret, and but we haven't actually created it yet. And all it needs to be is some small random string that we're going to generate. But this has to be a secret, and generally your playbook is going to be stored somewhere that it's not, that it might be somewhat public. For example, the playbooks that are used to deploy usegalaxy.org and usegalaxy.eu are all publicly available on the web, and so in GitHub. So because of that, we can't put our ID secret just directly here in the file. But for this, we use an Ansible feature called vaults, which is essentially an AES 256 encrypted file that gets decrypted at runtime when you run the playbook, but otherwise keeps that data encrypted so that it can't be read. So we need to create our vault file. And the vault file is protected by a password. So the very first thing we're going to do is generate a password. You can see then I've done this with OpenSSL, just randomly generate some base 64 text and stick it into this vault password.txt. Yours is going to look different from this, but that's what it generated in my case. Next, then in ansible.config, we need to tell it where that vault password file is. Of course, just having it as a file in the playbook isn't secure. It certainly wouldn't be secure if you committed it and pushed it to a public repository. So you want some other means to distribute this to the people who are going to run your Ansible playbook. But for the purposes of the training here, we don't want to have to type this password in every time. And so we're going to stick it into a file and then tell Ansible just to read it from that file. And finally, we're going to create the actual vault file itself that will contain the ID secret. So we do that with Ansible vault create. And you see we've been dumped into an editor here in an empty file. And so we're going to just put this vault ID secret. So you recall this variable name, vault ID secret, was the one referred to back in the regular group vars file. And so normally you generate a random string. I'll just use whatever is in the training. This is fine. But that's vault ID secret. Now, if I look at that file, you can see that it is this AES encrypted junk, and not, you can't read the actual ID secret that I put in there. But when I go to run my playbook, that vault ID secret that was placed into that file will be substituted in here and read into the Galaxy config in the ID secret option. Finally, we just need to tell Galaxy or Ansible to load that secret file, which we do using this vars file option. So in a standard Ansible playbook layout, the things in the group vars directory are automatically loaded if they match a group that the host that you're operating on is in. So you recall that in the hosts file, we put, I'll open up the hosts file. In the host file, we have our server name here, and it's in the Galaxy servers group. That's how the group vars Galaxy servers variable file automatically gets read. But the secrets file is not automatically going to be read. And so for that, we add this extra vars files option to the root of our play. Oops, I'll put it up here to be consistent with the training. And this tells it, okay, load those variables, even though you're not in a group called secret. All right, and now we should be ready to run the playbook. And this is going to, what's it going to do? What did we do? our playbook file, galaxy.yaml, we added these new roles. So it's gonna run the PostgreSQL and PostgreSQL objects roles again, but there shouldn't be any changes. Now, though, we've added the pip role, the Galaxy role, and the Miniconda role, and those are all new and should run after the Postgres roles. So let's see. So far, I don't see any yellow. That's a good sign. Means that nothing changed. Okay, there's the first thing that changed. Create Galaxy user. So now there should be a system user, a Linux system user named Galaxy. Next thing that happens is that we created the Galaxy root directory. So we had set that to serve Galaxy /serve/Galaxy. And then it created a bunch of paths under that. And you can see it created some privilege separated. So these VM and server and config and local tools are all going to be owned by the root user, whereas these directories that Galaxy itself needs to write to are all going to be owned by the Galaxy user. The next thing it did, scroll back up here, was to clone Galaxy. So there was no Galaxy installed to begin with. And you can see after it finished, it told us that, said Galaxy version changed from nothing to this commit ID, which should be the latest commit on the release 2009 branch in the Galaxy repository. And it created the Galaxy virtual env. It made sure that pip and setup tools were the latest version in that virtual env. And then removed the PYC files that I mentioned quite a while ago. All right. It then created the Galaxy configuration file, galaxy.yaml, and is installing the base dependencies. So it's doing essentially a very large pip install of all of the dependencies in Galaxy's requirements file. And this process will take a while. So while it's doing that, we can actually have a look at what has been done so far. So I said there's a serve Galaxy, and in here you can see these directories. Inside of config, there's a galaxy.yaml, and you can see the options that we put in there, not exactly with the same spacing and ordering and everything, but the options that we put into that Galaxy config variable in our group variables file have now been placed into the galaxy.yaml file, Galaxy's config file. But there are some things in here that we definitely didn't define. Shed data manager config file, we didn't define that. Integrated tool panel config, job metrics file, whatever. We didn't define these things, and that's because the role does it for us. It needs to set the paths to all these files that are not in the default place where Galaxy would look for them, because we have a separate config directory outside of the Galaxy directory. And so because of this, it knows to set all these additional options for us. That way we only have to set the ones that we care about in our group variables file. Additionally, you can see that it substituted that ID secret in from the vault file. So that went successfully. All right, let's go back to Ansible now, which has done a bunch of things while we were gone. Oop, can't scroll back that way. You can scroll back this way. Okay, so you can see, okay, it installed the base dependencies, then it installed conditional dependencies. So for example, it's installed the Python psychopg2 library into the virtual env so that it can connect to the database. Then it created the mutable configuration files. It does that once when the new Galaxy server is created, and then it should never do them again. It shouldn't overwrite these files because Galaxy is going to start writing to them, but it has to have them in place to do that. The next thing it does then is check to see whether or not the client is built, and it finds out that it is not built. and then it goes through the steps needed to do that. So it installs Node.js, installs Yarn, and then it runs the make client production to build the client application. This process will take quite a while. Depends on the size of the system that you're running on, but yeah, you'll have to wait a bit for this. Okay, and we are back. I cheated and cut out a little bit in between there while we were waiting. But as you can see, after finishing the client build, it moved pretty quickly on to the Miniconda role, installed Miniconda. And then at the very end, you can see that there is a handler that ran. But the handler actually is just a message that says restart or not implemented. Please restart Galaxy manually. So Galaxy is not running yet. And the reason for that is that in a bit, we're going to set it up to run under systemd. And doing so will automatically set up a handler for us. But as of now, the role doesn't know how we want it to start Galaxy. So we'll fix that shortly. Okay. So we looked at the Galaxy config file already, and we can go and poke around at a few other things under serve Galaxy. So you can see the Galaxy server directory here, of course, is just the Galaxy clone. There is a jobs directory created for us. That's where tools will actually execute. And then there's this var directory that contains a few things like config files that Galaxy is going to modify itself. And then there's the virtual env. So let's take a look in var specifically. This contains things like the Galaxy tool dependencies. So the Conda that was installed is under here. You can take a look there. And then in the config directory, these are the things like the shed toolconf, where when we install tools from the tool shed, their definitions will be written here. But right now it's just empty and defines basically just the path where tools will be installed, the tools themselves, not the definitions. And that directory has been created for us as well. So everything is ready to go with our Galaxy server. We just need to get a web server in front of it so that we can actually access it. Oh, but before that, we need to actually set it up to run. And for that, we're going to use systemd. So if you're not familiar, systemd is essentially the Linux init system now. So it manages, it's basically the first thing that starts after the kernel starts. It manages all the processes that start and run after that. So we're going to schedule essentially Galaxy to start up when the system starts up, the same way that you would for any other server process. So this is done by the Galaxy role. So back in our, let's clear this out and go back into our playbook. And then in the group vars, Galaxy servers.yaml, we can tell the Galaxy project.galaxy role that we want to use systemd to manage Galaxy. Now, this wouldn't be applicable on systems where you don't have the ability to start, set up services to run at boot, or if you're not using systemd, something like that. But it probably applies to 99% of Galaxy servers at this point. So we're going to, we've added that one option that tells the role that, yes, go ahead and use systemd. And then we'll go ahead and run the playbook again. And you can see, as expected, there aren't changes to most of the things that are being, most of the tasks that are being run here. So, you know, there are these options to, well, basically everything that's happened so far has all been just no changes. Sometimes it does take some time because it has to verify that there is nothing that needs to be changed, but yeah. All right, now we're down to the point where it is installing the Galaxy unit. That's systemd talk for the service file that describes the service that's supposed to be run. So we can actually look at, well, let me point out first that now it ran a handler that says Galaxy Mule restart, which is the handler that is automatically been set up for us, so that now anytime we make a change to Galaxy's configuration or anything else that requires a Galaxy restart, it can actually be restarted for us. So if we take a look at the systemd system galaxy.service, there's this service unit file, and this tells systemd how to run the server. So it says set the working directory to where the Galaxy code lives, and then run uWSGI with the YAML option to point at Galaxy's config file. And we set some other options here. The role documentation will tell you more about things that you can set, but for the most part, this is fine for our purposes. And now, if I do a system control status Galaxy, it should show me that the Galaxy service is running. It's running with 4 processes, which if you look back in the uWSGI config section of our variables, you would see that we had told it to run with 4. There's a memory limit. You can see in the service unit, it's defined as 16 gigs. So if it were to ever exceed 16 gigs, it would automatically be killed and restarted. But this is great. This is good news. And you can see there's also the contents of the log file here from Galaxy, which you can view with journal control. So this is another part of systemd. It's log collection service, journald. So you do this with journal control -eu Galaxy. The E tells it to go to the end of the log, and the U tells it what service to look at, what service unit. So you can see this is Galaxy's log, and we won't go into detail about this, but if you've ever started up a Galaxy server before, this should look familiar to you. But now instead of a file, it's in the systemd journal. All righty. Another point that is made here is that you can also, if you have to restart Galaxy by hand for some reason, you can always do that with system control. If you're familiar with managing services with systemd and system control, it's the same way that you would with anything else. So sudo system control restart Galaxy would restart it. You also, I use journal control -eu to open it in less and view, be able to scroll around in the log. If you want to follow it like you would do a tail-f on a log file, you can do journal control -fu. And now if there were things actually appearing in the log, you would see it scroll. But of course, nothing's interacting with our Galaxy server right now, so there's no new log messages. One thing that's important to note about handlers now that we're using a restart handler, is that if your Ansible if your Ansible playbook fails during the execution of it, and something happened that would have triggered the handler to run at the end of the playbook, and you go and fix whatever caused that error, and you run the playbook again, but the thing that triggered it was before the failure, right? And so that task has already been done the first time you ran it. Now you run it a second time, there's no change, and so it doesn't know that the handler needs to run again. And so this is sort of a gotcha with running Ansible playbooks. And you just need to be mindful of the fact that if a playbook runs and changes some stuff and fails in the middle of running, that there may have been handlers that should have run afterwards, and you're going to have to manually do the things that those handlers would have done. Okay, we have Postgres running. We've got Galaxy up and running, managed by systemd, connected to Postgres, but unfortunately we can't access it yet. So uWSGI can serve HTTP for us directly, but it's not a production configuration. Running Nginx or any other reverse proxy, but we use Nginx, gives us some additional features that are very nice to have: compression, caching, static content serving, and so forth. So we're going to move ahead with setting that up. So the first step is to open up our playbook file and add a new role to the bottom. And this time we are going to add the Galaxy project.nginx role, which, as you might imagine, is going to install Nginx for us. So that's the only thing that needs to be done in here. And now we need to configure what that role is going to do. And as the case with all the roles, this is done by setting variables in the group vars file. So let's open that up. And down here at the bottom, we need to add a new section that will control certbot, which will get us some SSL certificates, and the Nginx role. Now you might be wondering why we're setting all these certbot options when we only added the Nginx role to our playbook. And the reason for that is because certbot and Let's Encrypt certificates work in a very specific way, where you have to have a running web server. And then after that running web server is serving on the internet, then you initiate a connection to the Let's Encrypt servers using certbot, and then it has to verify that that web server is functioning. And only after that point can you set up SSL on that server. So we need to run the Nginx setup tasks in sort of two stages: one to set up the basic HTTP, and then a second time to run SSL. And because of this, we have integration in the Nginx role, where it will run the certbot role in the middle of it to allow this process to happen. So explaining these certbot options, you can see that we have some control over when it renews certificates. We have control over the authentication method for getting new certificates. And we're going to use the simplest, which is webroot, where certbot places a file on the web server somewhere that the Let's Encrypt servers will look for when they go to validate that you own that web server. That lives under the certbot well-known root, which is defined down here. And this is a path that gets served by the Nginx web server. We're going to install certbot into a virtual environment so that we can run the latest version of it. and set a couple of options to make sure that the certificates stay up to date. And then the most sort of important option under here is the certbot environment. You can see that we have this set to staging, but the reason for that is that there are limits on the number of production, which is to say trusted, real Let's Encrypt certificates that we can get in a time period. And so we use the staging environment, which will give us invalid certificates, but we'll actually be able to get enough for everyone participating in the training if we do this. Also, it's just good practice to use the staging environment until you have a production-ready web server that you know is ready to use, because sometimes you have to wipe things out and fetch new certificates, and you don't want to be doing that multiple times in the production environment. Okay, we've configured certbot to share keys with the Nginx user. That means that when Nginx starts and runs, it'll be able to read the keys, the SSL certs and keys on the system. Configure it so that when new certs are obtained, that Nginx will be restarted automatically. And we say, importantly here, that the domains that we want our certificates for are this inventory host name, which is an automatically set Ansible fact that matches what we've put in the inventory for this server. So this is why it was very important that the DNS name be correct in our inventory file, because the certificate name has to match the name that we're going to put into our address bar when we go to view our Galaxy server. If they don't match, then that certificate is invalid. And finally, we have an option to automatically agree to the terms of service here. Down in the Nginx options settings or section, we have an option to make it so that the proxying works if SC Linux is turned on, although it's not the case on the training instances or VMs that we're using here, but it's necessary on other environments. We also have then two options. One defines the virtual hosts that will be available prior to when certbot runs. That's Nginx servers. And this is just a basic HTTP virtual host that will serve the certbot well-known root directory so that Let's Encrypt can verify that we own this server. But then all other requests will be redirected to the SSL virtual host, which is set down here under Nginx SSL servers. And this is the actual Galaxy virtual host. This is what serves Galaxy. Okay, we want to disable any default server that runs most distributions of Linux. When you install Nginx, it sets up a default server. We don't want that. And we set one a generic sort of option that goes into the HTTP part of the Nginx server config. And this is to increase the maximum body size so that you can upload large files. Although in a modern Galaxy application, the file is split up into chunks, and then those chunks are uploaded. So you shouldn't have files uploading this large by default anymore, but it's still a good idea to increase it, because there are some circumstances where it may be necessary to upload larger files without the chunking. Okay, so as I mentioned, the Nginx role has this ability to run a role in the middle to fetch certs, and that's defined by this Nginx SSL role option, where we've said we're going to run the use Galaxy EU certbot role. And then finally, we give the path to the SSL certificate and the corresponding private key that will be installed by certbot when it runs. Okay. And it is possible to use different SSL certificates. That's explained in this section here. And it is possible also not to use SSL at all, although that's very much not recommended. And since we're trying to help you set up a production Galaxy server, we don't cover that. Okay, so that's it for the settings. But I mentioned that there's these virtual hosts. I'm using the Apache terminology here, but these virtual hosts of a non-SSL and an SSL virtual host that need to be set up, and we have to create the configurations for those. And so we do that by creating templates. So this will be our first set of templates. So we need to make a directory, templates, Nginx. And this is in the Galaxy directory. So again, if you CD'd into group vars, make sure you CD back to the Galaxy directory. I've made this directory and I want to edit this new file. Whoops. I'm going to do this. Okay. And now I'm going to paste in the contents here. And what we have is just listen on the default web port. The server name is that inventory host name again. It's our server. And then we have this special location here for the well-known place that the Let's Encrypt servers are going to look. And that location will point to a place on our file system that is given in the certbot well-known root a variable. So certbot is going to place a file here, and then it's going to say, hey, Let's Encrypt, go check, because I put this file here, so I can prove that I own this web server, and Let's Encrypt will do that, and then we'll get certificates. Every other request then that doesn't go to the well-known directory then is proxied to the HTTPS version of the website, or redirected to that. So that is it for the basic configuration. Now to the more interesting one, templates Nginx Galaxy, which is the virtual host configuration for our actual Galaxy server. We'll just copy that in. And back up here at the top, you can see that this starts out similarly. We have a listen directive, although it's listening on the SSL port. And then most requests are going to be proxied to using this UWSGI pass option to the value from the Galaxy config option, our group variables file, .uwsgi.socket. So again, I'll open that up. We have this variable up here that we've set, Galaxy config, and then under the WSGI section, and then the socket. So again, we've only defined this once in right here, and then we reference it in the template. That way, I could hard code the port in here directly, but if I did that, then I'd have to change it twice if I ever needed to change that socket address. So most routes go to this using the UWSGI protocol. It's a native protocol that's supposed to be more higher performant than just a straight HTTP protocol between Nginx and UWSGI. So in addition, then we have these other routes where static content is going to be served directly by Nginx. So these requests to anything at /static, so that includes like the style sheets and the JavaScript and so forth, will not be served by Galaxy. They'll be intercepted by Nginx and served directly. We've also got the welcome page, which actually lives at this sample, but you can change it later. And if you do, then you just remove this directive. Some setup for interactive environments, and then robots.txt and favicon, just to round that out. Okay, but that's it for the Galaxy virtual host. And now we should be able to run the playbook. Oops, Ansible playbook, galaxy.yaml. And again, this is going to run through all of the stuff that we've done so far, but it should mostly be, or all be, no changes until we get to the Nginx steps. Okay, here we are in the Nginx role. You can see it's taking its time here to install via apt, which is the right pick for our operating system. All right, what else did it do? Disabled the default virtual host. You remember we set a variable that told it to do that. Set additional config options, such as that 1 gig body size. And then it's installing the non-SSL virtual host configs. There. Installed it and enabled it so that it was live, and then forced the handlers to run. So I mentioned that the handlers always run at the end, but it is possible to force them to run earlier when you need them to. And in this case, the role needs them to run earlier so that the non-SSL config gets read and is available when the certbot runs. Okay, so at this point, it hands off control to the certbot role, and then certbot gets installed into a virtual env as we told it. It creates that well-known directory and then proceeds to request the certificate. And you get the output here, which is very helpful, and to verify that it got what you want. Tells you where the paths of the certificates are and so forth. And then writes the script that will make sure that the copies of the certificates are in the right places where Nginx expects them afterwards, and runs that script, sets up a cron job to make sure that the certificates stay up to date and renewed. And then now you can see here, control, so certbot has finished what it needs to do. And the certbot role is finished, and hands off control back to the Galaxy project.nginx role. The Nginx role then proceeds to do SSL setup, so configures options and so forth, and then installs that SSL vhost that serves Galaxy, and then triggers those handlers to run once again, reload Nginx, and it should be done and ready. So you can see the changes that were made if you take a look at Etsy Nginx sites enabled. This is a Debianism, I suppose, where there's a directory called sites enabled under Nginx that contains symlinks back to the same files in the sites available directory. And so if you don't have to remove your configs, you can just add or remove symlinks to control which virtual hosts are enabled. Anyway, as you can see, there's the redirect SSL and the Galaxy virtual hosts. And if we take a look at Galaxy, for example, you can see this is that template, but with values filled in. It's filled in my server name. It's filled in the host and the port for the UWSGI server, the UWSGI connection to Galaxy, and so forth. So I should now be able to access my Galaxy server. Let's see if it works. Oh, GAT42. training, galaxy.project.eu. Okay, this is a good sign. If it didn't make a connection at all, that would be a bad sign. So we're getting a privacy warning, and this is because we're using the Let's Encrypt staging environment. Your browser doesn't trust certificates issued by the staging environment. They're not trusted certificates. But in our case, that's fine. And we're going to be working with these certificates throughout the training because we don't have the option of getting correct certificates. And these are throwaway instances anyway, so that wouldn't be a very good thing on our part to be using real ones. So I click through and allow that certificate, and you can see here's my running Galaxy server. It's got the brand that we set, and everything looks fantastic. Okay. So the next step will be to log into Galaxy, and you can do this. You need to know what your admin user was. So I set mine to my own email address. If you just copied the Galaxy config out of the training materials, it's admin@example.org. But if you're not sure, you can always look. Let me clear this. Yep. Admin users, group vars, Galaxy servers, and you can see here mine is my email address. So Galaxy, when you install it, doesn't pre-create these admin accounts for you. The first person to actually go and register it would be the one who gets it. Although, yeah. So of course you have to use that email address that you put in admin users. So put this in. Oh, no, wait, I meant to register, not log in. A very secure password. Whoops. And there we go. Because I'm logged in as administrator, I now have this admin option up here in the masthead. And click through. And now I'm in the administration side of Galaxy. Great. So we have a running Galaxy server. The next thing that we want to do is set up the job configuration file. And in this exercise, we're actually not going to configure it to do anything special in more than it would normally do with its default job configuration. But we're going to use this file a lot throughout the week or the training. And because of this, and because it's one of the most regularly modified files, the first thing that you're going to do when you're setting up a Galaxy server at your site is modify this file. We'll cover it right now. So this is the file that controls how Galaxy actually executes jobs. Galaxy's has been designed to be very extensible and to be adaptable to almost any modern cluster or job execution system that is out there. And later, in a later training, we cover connecting Galaxy to Slurm, but there are many, many different options, and you can look through the Galaxy documentation to learn about all of those options. So as mentioned down here, the default option is to run jobs on the local server, which is our VM where we're running Galaxy, but common options include Drama, which is just a library to interface with lots of different clustering systems, which support many things such as Slurm, Condor, Torque, and Grid Engine, and more. And then there is Galaxy's own remote execution engine called Pulsar. And this is the only way that you can execute jobs on systems where you don't have a common shared file system between Galaxy and the cluster. So by default, Galaxy expects that all of the data sets that it sees on the file system are also available at the same path on the cluster, and sets up the jobs to run as if it was running on a cluster head node and was writing a script, a job script, and was going to execute it right there. If you don't have that, if your Galaxy server is running somewhere else, then you can use Pulsar to actually stage the job data in and out of your cluster. And that will be covered in another tutorial. Okay, so when you're looking at the job configuration file, it has three basic sections. There are the plugins, there are destinations, and there are tools. So the plugins section defines what job runners are going to be loaded. Job runners are essentially the different interfaces between Galaxy and your cluster scheduler. So there's a job runner for Slurm, there's a job runner for PBS, there's a job runner for Condor, there's a job runner for local jobs, and that's the default one. So those are loaded in plugins. Destinations are how define how jobs run through those plugins. So every destination says, I run with this particular plugin, and then it allows you to define additional parameters about how jobs should run on that plugin. So destinations are a many-to-one or many-to-many, I guess, mapping. So you can say, I have 5 destinations. One is just the basic, just submit to the cluster with 1 core and whatever the default amount of memory is, and that's it. And then the second one, it's like 4 cores and twice or more memory, and so forth. But it submits to the same cluster. The third one goes to a special queue, maybe. And so that's what the destinations are for. They're defining how jobs run on those different plugins or runners. And then tools, the tools section allows you to map specific tools to destinations. So most tools in Galaxy fall into 2 or maybe 3 categories. So the majority of tools in Galaxy, they're not multi-core, they only need a single core, and somewhere around, between 2 and 8 gigs of memory, depending on the inputs and parameters and the tool. Typically, I just map those to sort of a default destination that gives them a small amount of resources. But then there are some tools that typically run with more cores. They have better performance if you can allocate more cores to them. And a lot of times those tools need more memory. And then there's the sort of large tools that need huge amounts of RAM and typically the same number of cores as the multi-core tools, but a lot more memory. So the way that you map these tools to different destinations that provide different amounts of resources is via the tools section of the job config. So here's what it looks like. This is in fact the default job config. It defines one plugin called local. That's its identifier, and it's a runner plugin, and it loads this code in the Galaxy code base, which is the local job runner. We have 1 destination, and because there's only 1 of them and there's no default defined on this destinations tag, this is the default. The destination's name is local, and it uses the runner plugin named local. So that local here maps to this local there. And then we haven't set up any specific tool mappings because our Galaxy server has no tools, essentially. Okay. So we're going to go ahead and create a job config file for our Galaxy server to use. So we need a directory called templates Galaxy config. We should already have a templates directory, but we probably don't have a Galaxy directory. Just do make-dir-p templates Galaxy config. And we're going to create this jobconf.xml.j2. And in here, we'll paste the contents of the jobconf file. And that's it. Now, we've modified this slightly to make it a little more obvious what's happening here. So we've explicitly stated that the default destination is the local destination. We've also said that the ID of the local destination is local destination, and the ID of the plugin is local plugin. Just so it's clear, you saw in the previous example, both in the destination, both the ID and the runner were local, and it wasn't clear what they referred to. So that's the reason for the differences here. So that is our job configuration file. And now, one thing to point out here, you can see that we have this option in the plugins tag called workers equals 4. And what does that mean? That means for the local plugin, it means that the local plugin can execute 4 jobs concurrently. And actually that's per handler. So in our case, if you remember, we ran 2 mules. So that's 2 job handlers. So that means that up to 8 jobs would be running concurrently if users submitted them. For every other plugin that's not the local plugin, that means the number of threads, Python threads that'll be started so that Galaxy job handlers can use that thread pool to do all the tasks related to setting up jobs and finishing them up. Sometimes there are things that block on IO in there. And so having a thread pool to be able to handle that work increases the throughput of handling jobs. All right, so we've created that file, but we need to tell the role where that file is, where it will be installed, or where it should install it to, and then where to set in the Galaxy config that path to where it's installed. So that will be in our group vars Galaxy servers file, and we're gonna go down here underneath ID secret, but above UWSGI in the Galaxy config variable. So this has to go in the Galaxy section here. Make sure you're in this Galaxy section, and then paste in. It looks like it doesn't line up. If you see in the diff here, that's just because the diff is hiding some stuff from us. But if you paste it in, you should see that it lines up. This job config file needs to be at the same level as ID secret. Okay, and this says, this configures Galaxy to say, look for the job conf file in the config dir at jobconf.xml. And then we need to tell the role to install it. That means copy it from the playbook, the template that we just wrote, template it over to the Galaxy server. So, whoops. I'm going to do that right under the Galaxy config variable. We'll create a new Galaxy config templates. This diff is a little bit off here. You need this Galaxy config templates, and then copy the 2 lines below it and paste that in. So you have Galaxy config templates, and then you have this list that starts with 2 spaces and then a dash, and then this source and destination. And I showed you this construct before, but just to go over it again. So the source is that file that we just created with the job conf in it, and then the destination refers to galaxy config.galaxy.jobconf file, which is a job config file, which is the option that we just added here. So again, the path to the file on the Galaxy server is only defined once. And we should be able to now run our playbook. And as the training said there at the very end, we should see that it has restarted Galaxy for us because we've added a new config file and we changed galaxy.yaml. Anytime you change galaxy.yaml, the Galaxy project.galaxy role is going to say, okay, I need to restart Galaxy to reread that configuration. So what did it change? Change the Galaxy config file you can see there. Just scrolled off the screen, and it copied the config template over from the playbook to here's that templated value, serve Galaxy config jobconf.xml. All right, there's the handler. It ran not quite at the end of the playbook because there's this task in the Nginx playbook that flushes handlers, so it runs then, but that's fine. It ran. We can also verify that the job config file was installed by running cat on it at its path in the serve directory. And there's nothing to view in Galaxy because nothing has changed as far as it goes, but we can at least confirm that this step completed. So there are some additional options that we might now want to set for a production Galaxy server, and we can copy these into our group vars. And then I will explain what these are. So I mentioned the server-side cursors in the database slides and the slow query log threshold. And then there is this option for Nginx XXL redirect base. What this is a nice feature in Nginx where if someone makes a request to a proxied web application like Galaxy is, and the response is just going to be a file off of disk, instead of responding with the content of the file, Galaxy just sends back a header in the response that's called XXL x-xl-redirect, like this. And then Nginx will intercept that, see that it's in the response, and return the file that's in that header. So it might say data, data set UUID, whatever, .dat. And instead of, and then Nginx will just send that file back, probably way faster than Galaxy, which is Python application, would do it. And it makes it so that if you restart Galaxy in the background, that transfer, that download that the client is making is not going to be interrupted. And you get this pretty much for free. There's a option, or there's a little bit of configuration that needs to go into the Nginx config file, the virtual host for this, but this is the only option for the Galaxy, or that has to be set on the Galaxy side to make this work. Okay, we have some additional niceties here. Later on, when we start adding dynamic job rules, which I'm not going to explain right here, we'll explain it later, but when we add those, you can make Galaxy watch and automatically reload anytime that those change, so you don't have to restart Galaxy just to update those. That can be done with this option. In Galaxy data libraries, which is data that is stored centralized that anyone can access and import into their histories in Galaxy, administrators can add to that. And this path paste option makes it so that they can just put in file system paths to import data directly into those data libraries. Quotas, so Galaxy has a full quota system, keeps track of the data that users use and create and own. and then you can set quotas on them through the admin interface in Galaxy or via the API. By default, users can't be deleted, so this option allows them to. The expose options are sort of privacy-centric options. It's possible that this could expose certain information that some sites may not want to. These are explained in detail in the documentation. So at docs.galaxyproject.org, click on admin and go to the configuration section. It explains these options. There can be some issues with NFS attribute caching that can cause problems when jobs finish. And so this option here, retry job output collection, will, if that attribute caching is causing problems, it'll just retry after a small waiting period until things work. And then finally, there are these cleanup job options. This controls whether or not the job directories where Galaxy's jobs run get cleaned up after they're completed. So by default, they will get removed no matter what, whether the job finished successfully or if it failed or whatever. But with the on error option, they'll be left behind if the job fails, which makes it way easier for you as an administrator to debug that problem. In addition to that, when you're helping users debug problems, this allow user impersonation option is a huge help because it allows you to go into the admin interface as an administrator and then log into their account and see exactly what they're seeing in Galaxy, which is a huge help when doing support in Galaxy. Finally, we have this outputs to working directory option. So normally a tool, when it runs in Galaxy as a job, writes its outputs directly to that file's path that we set at the very beginning, actually further up here, which is set to /data. Instead, if you enable outputs to working directory, what happens is that the tool's outputs will be written to the job directory instead of the files directory. And then Galaxy will move them back afterwards. And this is a crucial setting for enabling running jobs inside of containers later, because the file path will be mounted into the container read-only for basically safety, sandbox, security reasons. And so outputs to working directory allows the tool's outputs to be written somewhere that is a writable path outside the container. Okay, so I mentioned that you have to set up the XXL redirect option in the Galaxy virtual host, and here is the way to do that. So we'll open up templates nginx galaxy.j2, which we've already created, and just down here at the bottom, inside the last curly brace, but outside the one above, whoops, we're going to paste in this. There's actually two directives here. So the first one does that XXL redirect that I talked about, and the second one allows you to use GTN in Galaxy. So if you load up the GTN, the Galaxy Training Network, from the masthead menu up here, and you enable, whoops, it's the training option, and you enable it, and you have this option set in your nginx config, then when users view the tutorials that actually execute tools in Galaxy, they can click the execute or the buttons inside the tutorial and it will run the jobs on your server, which is a really, really nice feature for people following along trainings on your Galaxy server. Okay, so with all of that set, we can now run playbook one last time. And all of those options will be set. Galaxy will be restarted, and it will be a really nice functioning production Galaxy server. So what happens if disaster strikes? Well, we can simulate that, and in some trainings we do, not online asynchronous trainings, but sometimes in person we like to do this. And so I can show you here in a minute. If I remove everything that we've done today, not the playbook itself, but if I remove everything that the playbook is installed, for example, installing all of Galaxy and stuff under Serve Galaxy, as long as the things that can't be recreated, such as the user data and the database, the Postgres database, as long as those things are backed up somewhere or on a separate machine, then I can blow up this entire VM and restore it essentially just by running the Ansible playbook again, right? So if that data directory, that /data directory, was actually on an NFS mount, and this VM ceased to exist, and we brought it back up, completely wiped out, all I would have to do is run the playbook again, restore the database using the database backups that were on the /data, and then everything would be back to normal. A functioning Galaxy server all the way back from the beginning. So why not? RM-RF. So as you can see, everything is gone. All of Galaxy is gone. And all I have to do to get it back is run my playbook again. So that's the real value. It may seem complex, and putting together the playbook and making it all work is probably more time than it would take to just type apt-get install Postgres, apt-get install Nginx myself. But the whole point is now everything that I've done has been recorded into this procedural set of actions that will be replayed again exactly the same way if I ever need to run them again. And every change that I make to my Galaxy server, all of the config changes, they're all recorded. So it can always be recreated exactly the same way. This is a huge, 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 huge benefit. So this will take a while, especially as it needs to rebuild the client, which is a long process. But we'll move on to talking about some other stuff. For example, maintenance and time needed to run this. Running a very large Galaxy server like usegalaxy.org or .eu is a full-time job. Although we do find time to work on other projects as well. For a smaller server that maybe supports a lab, you could expect to need to spend maybe a day or two a month dealing with Galaxy, cumulatively over the period of the month. As you saw earlier, there's the Galaxy commit ID option that controls the version of Galaxy that's being run. We set it to release 20.09, so from September of 2020. And upgrading your Galaxy release is typically as simple as updating the Galaxy commit ID to the current release or the one that you want to run. Generally, you want to go and read the release notes and stuff to find out all the stuff that has changed, but it really is that simple when you're using the Ansible playbook. There is a separate training that you can go find that covers upgrading Galaxy in more detail. For support, there are built-in links in Galaxy that go to our discourse site at help.galaxyproject.org, which is a great place for user support. And of course, for administration support, development, and also user support. We have channels on Gitter that are pretty much always populated by people who are part of the Galaxy community and the Galaxy team. And so we're happy to help and be here for you and your users. I talked about user impersonation, and so I won't cover that, but one final thing here, when running Galaxy on a cluster, which almost all of you will certainly do. So the way that we've installed Galaxy currently, everything lives under that serve directory /serve/Galaxy, except for the data sets, which are on data /data. There are these Ansible variables that you can set that are defined by the Galaxy role. And these are the ones that have to be on a shared file system. So that is a file system that's mounted on both the Galaxy server and the cluster where you're running jobs, and it has to be mounted at the same path on the cluster and the Galaxy server. So that is the shed tools directory where Galaxy tool shed tools get installed, the tool dependency directory where like the dependencies of the tools themselves get installed, usually conda packages, the file path, so that's that /data, the job working directory, which is where jobs execute, server dir, the Galaxy code itself, and the Galaxy virtual env directory. So if you set all of these to paths somewhere on your shared file system and redeploy Galaxy, then it should be able to operate on a cluster. And there is some additional information about running on a cluster and shared file systems and so forth in this section that is good to read if that's what you're doing. Okay, so that is pretty much it. If you have made it to the end here, then you have essentially what is in this picture. There is a Galaxy application that's running. It's connected to storage. It's connected to compute, although our compute is just local at this point. It's connected to a PostgreSQL database. It is being served by UWHGI, and that UWHGI is proxied by Nginx. So congratulations, and thank you for joining me.